Hello everyone, it's Wilson here. Let's determine whether this improper integral is convergent or divergent. There are two reasons for why this integral is improper. One is that the integral has an infinite interval. The other is that when we substitute 2 into x, we get 0 in the denominator. So what should we do? We can find the antiderivative first. Now, let's recall that the derivative of secant inverse of x is 1 over x times the square root of x squared minus 1. Our integrand looks similar, but it's not the same. But we can still find the antiderivative easily with a little bit of manipulations. We can first factor out 4 from both terms inside the square root, so we get x squared over 4 minus 1. Then we can pull the 4 outside the square root and it becomes a 2 in the denominator. For this expression, we can write it as x over 2 squared. Next, we can do a u substitution, and we have an integral in u. Pulling out the 1/2, we have an integral that is the same as the derivative of secant inverse. So, we get 1/2 secant inverse of u. Replacing the u by x over 2, we get the antiderivative. We are now ready to compute the improper integral. The next step is to split the improper integral, and we write each as a limit of a definite integral. Our original integral converges if both of these integrals converge. Let's compute these integrals one by one. For this integral from 2 to 3, we first write it as a limit, with a being the lower limit and approaching 2 from the right. Since we already got the antiderivative, we can plug in the a and the 3. See that the secant inverse of 1 is 0, so we get the answer 1/2 secant inverse of 3 over 2. Now let's compute the second integral from 3 to infinity. Again, we write it as a limit of a definite integral. This is finite, so we don't need to worry about it. We'll focus on this expression when b approaches infinity. We can find this limit by looking at the secant graph. As b approaches infinity, b over 2 also approaches infinity. From the graph, we see that the secant of x approaches infinity when x approaches pi over 2 from the left. So secant inverse of b over 2 approaches pi over 2 when b approaches infinity. Thus, this approaches pi over 2. And our answer for this integral is pi over 4 minus 1/2 secant inverse of 3 over 2. So both integrals are convergent. Our original integral is also convergent, and we can find its value by adding the two integrals. These two get cancelled. So our final answer is pi over 4. If you like this video, please subscribe and share my videos to others. Thank you. I will see you next time.